Welcome to today's ArXiv CS Digest for March 17, 2026. We received 797 new computer science papers today across 58 subfields. Let's dive into the top picks. Trend 1 of 5, Scalable and Robust ML Operators. This trend designs ML operators for inherent efficiency, reliability, and resilience, enabling robust and scalable performance across diverse challenges. This cluster covers 148 papers. Representative work includes long-horizon traffic forecasting via incident-aware conformal spatiotemporal transformers, GIST, gauge-invariant spectral transformers for scalable graph neural operators, and thin keys, full values, reducing KV cache via low-dimensional attention selection. Trend 2 of 5, RL for robotic manipulation. Applying reinforcement learning to enable robots and physical systems to perform complex manipulation tasks, often leveraging simulation. This cluster covers 94 papers. Representative work includes MALMO-B0T, large-scale simulation enables zero-shot manipulation, DreamPlan, efficient reinforcement fine-tuning of vision language planners via video world models, and BrickSim, a physics-based simulator for manipulating interlocking brick assemblies. Trend 3 of 5, Generative Models for 3D Vision. These papers leverage generative models to create, reconstruct, and understand complex 3D scenes, objects, and their dynamics. This cluster covers 210 papers. Representative work includes WorldCam, interactive autoregressive 3D gaming worlds with camera pose as a unifying geometric representation, demystifying video reasoning, and SegViGen, repurposing 3D generative model for part segmentation. Trend 4 of 5, LLM interaction and evaluation. This trend investigates improving LLM interaction methods and developing comprehensive evaluation techniques for their capabilities, biases, and impact. This cluster covers 212 papers. Representative work includes Chronos, temporal-aware conversational agents with structured event retrieval for long-term memory, Social Omni, benchmarking audiovisual social interactivity in Omni models, and online experiential learning for language models. Trend 5 of 5, Real-world systems and impact. These papers optimize and analyze diverse systems, exploring their real-world performance, efficiency, and societal impact while addressing complex challenges. This cluster covers 133 papers. Representative work includes efficient reasoning on the edge, unifying optimization and dynamics to parallelize sequential computation, a guide to parallel Newton methods for breaking sequential bottlenecks, and transit network design with two-level demand uncertainties, a machine learning and contextual stochastic optimization framework. Up next, our first paper out of 5, MetaCrit, a critical thinking framework for self-regulated LLM reasoning by Xinming Ho and Qing Guo from Nanyang Technological University. Let's break down its key contributions. Proposes MetaCrit, a novel multi-agent framework inspired by Nelson and Narain's metacognitive regulation theory. This framework decomposes complex reasoning into distinct, self-regulated components to enhance LLM performance. Implements an object-level generation agent responsible for producing the initial response or explanation. This foundational component provides the raw output that subsequent agents will monitor and refine. Introduces a dedicated monitoring agent designed to assess the validity and correctness of the generated object-level response. This agent identifies potential errors or inconsistencies, initiating the self-regulation process. Develops a control agent that critically evaluates the logical soundness and truthfulness of the monitored response. This agent intervenes to correct identified issues, ensuring high-quality and reliable outputs. Integrates a meta-level synthesizer that combines the outputs and feedback from all agents. This final component consolidates the refined information into a coherent and critically sound ultimate response. Up next, our second paper out of 5, Amnesia, Adversarial Semantic Layer-Specific Activation Steering in Large Language Models by Ali Raza and Jaibesh Patra from Honda Research Institute Europe. Let's break down its key contributions. Amnesia introduces a novel adversarial attack framework operating directly within the activation space of large language models. This approach targets internal representations rather than external inputs, offering a unique vulnerability exploitation strategy. The framework specifically manipulates the internal transformer states, steering the model's behavior by altering its hidden representations. This direct intervention on activations allows for precise control over the LLM's processing. Amnesia effectively circumvents existing safety mechanisms in open-weight LLMs by manipulating internal states. This enables the generation of harmful content without requiring fine-tuning, highlighting critical vulnerabilities in current safeguards. Up next, our third paper out of 5, Functorial Neural Architectures from Higher Inductive Types by Karen Sargsyan from Institute of Chemistry, Academia Sinica, Taipei, Taiwan. Let's break down its key contributions. This foundational contribution compiles higher inductive type, HIT, specifications into neural architectures. It uses a monoidal functor mapping path groupoids of target spaces to a category of parametric maps, ensuring architectural compositionality. Path constructors within the HIT specification are implemented as dedicated generator networks. These networks are responsible for producing representations corresponding to the fundamental building blocks of the target space. Composition of paths is realized through structural concatenation of the outputs from the generator networks. This mechanism ensures that the combined representation inherently respects the compositional structure of the input. Group relations, represented by two cells in the path groupoid, are modeled as learned natural transformations. These transformations adjust representations to enforce equivalences, ensuring consistent outputs for compositionally equivalent inputs. Up next, our fourth paper out of 5, When Should a Robot Think? Resource-Aware Reasoning via Reinforcement Learning for Embodied Robotic Decision-Making by Jun Liu and Dong Huang from Robotics Institute, Carnegie Mellon University. Let's break down its key contributions. RARL is a hierarchical framework designed for resource-aware orchestration of embodied agents. It operates at the agent's decision-making layer, focusing on high-level strategic choices rather than low-level control. This policy learns to adaptively manage an agent's reasoning process. It determines when to invoke reasoning, selects the appropriate reasoning role, and allocates computational budget to optimize performance. The policy makes decisions by considering current observations, the agent's execution history, and available computational resources. This enables dynamic adaptation to environmental changes and resource constraints for efficient operation. Up next, our fifth paper out of 5, Omnilingual MT, Machine Translation for 1,600 Languages by Belena Lastory and Charles-Eric St. James from FAIR at Meta. Let's break down its key contributions. This strategy integrates large public multilingual corpora with newly created datasets, including manually curated medley bytext, synthetic backtranslation, and mining. It is crucial for expanding language coverage to 1,600 languages. This model specializes a Llama 3-based decoder-only architecture for machine translation. It incorporates multilingual continual pre-training and retrieval-augmented translation, enabling strong performance in low-compute settings. This architecture builds upon a Llama 3-based multilingual aligned space, Omnisonar, within an encoder-decoder framework. It introduces a novel training methodology that effectively exploits non-parallel data for enhanced translation quality.